All right, so before we get into the new stuff, just real quick, let's just do a little recap, just without it like sitting done in front of you from yesterday, okay? Just kind of what you guys went over. If I was going to do number one, rewrite in exponential form. So it's written with a log, so it just means rewrite it without the log. Loopy swoopy. So how would you rewrite this one? Good. If there is no number there, remember that is a 10. Do you realize that's another like unwritten number in math? Right? Like we say ones all the time. We had the unwritten 2 for square roots. Now there's an unwritten 10. Math gets more and more complicated. But yeah, loopy swoopy this. You got this now, right? So 10 to the negative 2 equals 0.01. All right, number 2, rewrite in log form. So it's still loopy swoopy. It's written, it's kind of just the opposite of this. How would you take it back to that? So first thing you do is write down a log, right? And then how does this one loopy swoopy? Which one goes where? What's the base number? The 8? Then what? Squared on this little base equals 1/3. Does it make sense? Loopy swoopy it the other way. Does 8 to the 1/3 power equal 2? Is the cubed root of 8 2? Yes. So when I'm loopy swooping, I'm always going like counterclockwise, and it's always the order I'm writing the numbers from left to right. Okay? Right, when I started here, the first thing I wrote down was the 10, then I wrote to the negative 2, and it equals this. Same thing here. I'm obviously going to write log, because it's writing log form. The first number I would write down would be the base number, right? So that's the first number. And then I'm going to write the 2, and then I'm going to write the 1/3. So loopy swoopy always is the order I'm writing the numbers in as I'm writing them down from left to right. Okay? Just got to kind of get that stuck in your head. All right, evaluate. So the easiest way to evaluate is to loopy swoopy it without the logs. We're doing this, trying to do this without a calculator. So this again is saying 7 to what power equals 343? 7 to what power equals 343? The third, yeah. I mean, you could create one. All right, and then this one. Again, think about what this is asking. 81 to what power equals 1/27? It's gonna be a root because it's making it smaller, right? Okay. So it's gonna be a root, so I know it's gonna be a fraction of some sort. I might not necessarily be a 1 there. It's gonna be a fraction, I know that, because it made it smaller. Also, it took my number and moved it where? Moved to the bottom, which means it's going to be negative. Now I gotta figure out the numbers. This is a hard one. This is like the 23, everyone wants Emma asked if that was a hard one where you switch the base numbers. This is a tricky one. Rewrite these. Let's do factor trees on these. Let's see what we got going on here. So it's not a real standard clean number system like some of these were. So the 81 can be written as 3 to the 4th, because I have 4 3s, right? So I can write that as 3 to the 4th. 27 is 3 to the 3rd. So the x goes with this one, so this is an x here. So what does x equal? Since these are the same, those would have to be the same. So if I have 4x equals 3, divide by 4, it'd be 3/4. So it's going to be a negative 3/4. Oh. Again, tricky one, because you had to change the bases on them. But the more I kind of throw those at you periodically, the better we'll get with them, I promise.
I saw you do that the last time, and I was like, what?
Did it make more sense the second time?
And now I'm getting it.
Again, we'll throw those at you once in a while. We'll get them. I'm not worried. I'm not worried. All right. So the new stuff for today is just talk about different properties of logarithms. We're not going to get through the whole notes today. We're going to only do part of them. We'll give you some time to get some work done, okay? Hopefully you don't have homework for the weekend. Okay, so there are three main properties for logarithms to help us to better solve them and simplify them, okay? The first is the product property. Looks beautiful, doesn't it? All those letters in there. All right, so all this is saying is I can take, if I have something being multiplied, I can pull it apart. We can expand them, is what it's called. So whatever that base number is, it's going to stay the same every time I rewrite it in this problem. That doesn't change. And then if it's being multiplied, it would separate with a plus sign. See, it took the u as the first one, and then it put a plus, and then it took the log with the v. It's almost like it kind of distributed it and kind of pulled it apart. Okay? Do we see that? Like, it's almost like it's technically, it's not distributing. But that's kind of what it looks like, right? It took the log and distributed to the u, and it distributed to the v. It kind of pulled it apart. Whereas we have the quotient property, if it's division, same idea, but it separates with a minus. Again, think about your properties for exponents. If it's a multiplication problem, what did you do with your exponents? You added them. If it was a division problem, what did you do with your exponents? You subtracted them. So the same idea of those properties, they still kind of follow through here. And then the other one, this is the one that's very different. If you have an exponent, you can take this exponent and you throw it out in the front, as now is an actual like coefficient. Weird, right? Exponent distributes out into the front as a coefficient that gets multiplied then by everything else. Hi. Hi. Okay, so those are the three properties. So today all we're going to look at is using these properties and simplifying with them. That's all we're looking at today. All right, so what is the expression written as a single logarithm? I want you to condense it. So using those properties, I can take different problems and I can kind of squeeze them back down into something more simplified. Notice they are both log base 4. So that way they match, they're like terms, so to speak. I can put them together. So I'm just going to write log base 4 one time. As mathematicians, we like to be lazy, right? I can rewrite it all as one log condensed. So what number, am I adding them? Am I multiplying them, subtracting them? When I put them together, what property is going to happen? It's subtraction, so I'm going to divide. So it's going to be the first one goes on top, the one right after goes on the bottom. So I have a 32 divided by 2, which you guys told me is 16. So that would be log base 4 of 16. Is that a nice answer? Log base 4 of 16 is...
You can simplify that because...
You're like, wait. Again, what's it asking? 4 to what power is 16? 2. It's 2. Because it's 4 squared equals 16. Again, you got to stop and really think about how those work. How are we doing? So I went from this ugly thing here. I used my property that was subtraction to make it division. I simplified that, and then I'm like, hey, 4 squared equals 16. You got to always loopy swoopy and see if it works. Will they always go down to a nice pretty number? That would be too easy to think that, but no, we always got to check that though. All right, number 2. So there's a plus in between. So that means I'm going to be multiplying. But wait a minute, there are numbers out in front. Where did those come from? That came from an exponent, right? Exponents, I can throw them out in the front. So I need to put this back as the exponent. So that's going to make that an x to the 6. We still have the log base 2. I just only have to write it once. Okay, don't forget to write it. Some people just forget the log entirely. It's still there. I'm just condensing it down to 1. And then plus means I'm going to multiply. Again, there's a number out in front, which means it came from an exponent of y to the 5th. Yeah. If it's a different base, you cannot condense them. I will give you same. I'll give you same bases. Yeah, we're just trying to get you to use the properties at this point. Now, can I do 2 to some power to get x to the 6, y to the 5th? No. Like here, I was able to kind of loopy swoopy this and get an answer. If I have variables going, you're not going to loopy swoopy nothing. Yeah, you're done. This is as far as I can go. So I was able to condense it down to 1, but I couldn't really do much else with it. All right, number 3. Again, I'm going to recognize there is a plus sign, which means I am going to multiply. Close, really close. So we'll go one step at a time. You just lost one little thing. But it's log base 4, don't forget that. And then you're right, I'm going to multiply those. So it's 5x times 3x. What's 5x times 3x? 15x squared. Quinn, you just lost the squared on it. And since there's a variable, can I loopy-swoopy? No. The times I'm looking to loopy-swoopy that thing is if I have just plain numbers, no variables, then I'll try to. All right, number 4, there's a minus sign, which means you are doing what? I'm dividing. So I have log base 4. I know I'm dividing, so I'll kind of just throw that in there. I have a number out in front, which implies it came from an exponent. So it was on this 6. So I really have 6 squared. I'm going one step at a time. If you can write down what that is right from the start, go ahead. And then the 9 goes on the bottom. So that's going to give me log base 4. 6 squared is 36 over 9. 36 divided by 9. So I have log base 4 of 4. Can I loopy-swoopy that one? 4 to what power equals 4? 1. See why loopy-swoopy is important? You always got to kind of think about that when you have plain old numbers. Questions on that one? Good. Yes. And sometimes it's hard to think in exponents and square roots because we don't typically think that way. All right, well, let's use the properties of logs to rewrite and simplify the logarithmic expressions. There's a lot going on right there. So we are going to use our properties to expand them. So we just looked at condensing them down to 1. Now let's kind of pull them apart and see if we can do something with them. Okay? So I'm going to have, so kind of what we're looking at is every single piece that's being multiplied or divided tells you how many times you will write the word log. So on number 5, how many times will I write the word log? 2, because I have 2 things that are being multiplied. Okay? So for this first one, it has an exponent on it. Where does that go? It goes out in front, so the 2 is going to move out to the front. Log base 3 of 9. Good. There's a multiplication, which means we're going to add. And I'm going to have another log base 3 to go with the second part. Good. The exponent's got to go out in front of 4. Log base 3 of 2. Do you like to expand them? That's kind of fun. I kind of like doing those. All right, can I simplify? Those are all numbers. There's no variables. Can I simplify any of them? So this is asking me 3 to what power equals 9? Yeah, good. So this part here is 2. But what about this 2? It's being multiplied. So that is 4. Right? Because this was 3 to what power is 9? 3 squared is 9, so that's where this 2 came from. And this 2 was already sitting out there. So that became a 4. 3 to what power equals 2? Is that a nice one? Try that. Does 3 to the negative 2/3 make 2? I can't do anything with that. So that's just going to be 4 log base 3 of 2. Now every year I have students look at that and go, oh, I can make that 8 then, log base 3 of 2. Can I add those 4s? No. That'd be like saying 4 plus 4x is 8x. No, it's not. They're not like terms. Okay. So I was able to clean up one of them, but the other one was, yeah, that was not pretty. All right, how about 6? How many times will you write the word log? Twice, because you have a 16 and then you have the x part, right? You have 2 things being multiplied. Log base 2. Base 2. Close. What do I do with an exponent? Yep, he comes out front, so that's just going to be an x there. Good. You're doing with the first part and the second part. Bless you. Bless you. All right, so log base 2 of the 16. If they're being multiplied, so it's plus, and then exponents get thrown out in the front, 3 log base 2 of x. Yes? We okay? Then this one doesn't have any variables to it. Can I loopy swoopy this one? 2 to what power equals 16? That's 4. And this one has a variable, which means I can't loopy swoopy anything, so that one's going to stay there. And we are done. Come on, kind of fun? A little bit? No? Neil says no. It is different doing a different subject in the morning than you have all the semester. What?
I like that we are doing it so early because I'm just adding my name.
So you're ready to go. Good. All right. We're Grey's Anatomy now? She said it's a great day to save lives. That's from Grey's Anatomy. Like many, many seasons ago, Grey's Anatomy. All right, number 7. How many times will you write the word log? 2, because you have a 6 and you have the 200.
So it's going to be log.
What's the base? That is log base 10. Now, before I even get started with anything, what's wrong with 6 over 200?
Oh, it's not simplified.
It's not simplified. Yes. I would rewrite this as 3 over 100. That's not simplified. How dare they give you a fraction not simplified?
So it's going to be log 10 3.
Log base 10. Make sure you say the base in there. Okay, log base 10 of 3 minus, good, log base 10 of 100. Now, how important was it that you actually simplified that first?
3.
It's very important because now can I loopy swoopy anything? 10 to some power equal 3? No. 10 to what power equals 100?
1
2. Yeah, it's hard. You got to think in terms of exponents. 10 squared equals 100. Had I not simplified and I left that at 200, and I said 10 to what power is 200, you'd be like, I don't know. But 10 to what power is 100, that makes sense. So log base 10 of 3, I can't simplify, minus, and this just becomes 2. 2. Quinn's more awake, but I'm not sure his brain knows that the rest of him's that awake yet.
No. No, it's just that my brain is very small and broken.
All right, number 8. How many times will you write the word log? Twice. Twice. So I'm going to have log base 7 of 1 minus, because it's division, log base 7, 147. All right, can I clean any of those up with loopy swoopy? Yes. 7 to what power equals 1? That's 0. Anything to the 0 power equals 1. 7, anything to the 0 power is what? It goes back to your exponent properties as you cancel things out. Kind of goes back to look, I love his explanation. Just type in your calculator, anything 0 power equals 1. Just do it, dude. I'll go over the explanation later if you want me to. I want to get through all this, though. How about this one? 7 to what power equals 147? What's 7 to the 3rd? That's 343. I know you're like, it seems like it should, but does it actually? It doesn't. So that's going to stay log base 7 of 147. Question, do I need the 0? Technically, I don't need the 0. Do I need the minus? Yes. So I could not write the 0, but I would still need to leave the minus sign there. If you want the 0 there, leave the 0. I don't care. If it makes you feel better. Number 9, she's just grading the vocab. Number 9, expand each log expression. So again, I'm asking you to expand. It means you're putting log on everything. So on number 9, how many times will you write the word log? 3 times. All right. So the fact that this is in parentheses, is that any different than this one over here that does not have parentheses? It is not any different. Nope. It means the same thing. All right. So I'm going to write log 3 times because there's 3 pieces being multiplied, right? So log base 4 of 5. And since it's being multiplied, you will put plus.
3 log base 4
Of x. Of x. Good. And then what sign? I need a symbol. Plus. There you go. And then log base 4 of y. You said that correctly. Thank you.
Tell me there's never a time where you're going to minuses and pluses.
Oh, we are.
Cool.
Can I loopy swoopy any of these? What's the only one I have a chance of? The first one, because there's no variables. 4 to what power equals 5? No, that doesn't do much. But you always want to check for that, because I will throw ones at you kind of randomly, like, nope, can't simplify, can't simplify, can't simplify. Hey, look, there's one little piece that simplifies. Okay, so you always got to look kind of through. Can I loopy swoopy any of these? All right, let me give you a second. Do number 10. All right, guys, number 10. How many times did you write log? 3 times. So we should have log base 10 of good. Did you loopy swoopy anything? The only one you could is the first one, 10 to what power equals 3? Yeah, it's not pretty. Why are you an idiot?
I said to myself, like, oh yeah, the x will be separate, and then I didn't actually.
Didn't make it separate.
Like when I went and wrote it down, I didn't actually get.
Did you write x, y?
I wrote 2 log 10 log base 10.
Of x, y?
No.
Oh.
Log base 10 3. How do you say that?
Of?
Of log base 10 of 3 plus log 10 y.
Just let me look at it. That's
Yeah.
faster.
Yeah.
You,
just
you
forgot
didn't
the
write
x.
the x at all.
Yeah.
Oh, okay. Ben? Correct. Yeah, it has an answer, but it's not pretty. Yeah, it would be a decimal that just keeps on going, right? So Quinn's question. You won't really give us multiplication and the division, so adding and subtracting together, right? Yeah.
Oh,
All right.
that's pretty
No, right there.
simple.
So let's stop for a minute. How many times will you write the word log? 4 times. The 4, the x, the 3, the y. Right? There's 4 pieces there. Will you have any numbers that get thrown out in the front of the log? No, because there's no exponents. Okay, so let's nice and slow because we need to talk about one thing that's going to happen here. All right, so you're going to have log base 10 of 4 plus log base 10 of x minus, because now we're dividing. Now, hold on. Here's where we're going to have issues. Well, yeah, because we need to make sure the 3 and the y both are where? On the division part on the bottom. So what should I do with the whole 3y part then? To ensure they stay together? Parentheses. Because I'm like, hey, I want this entire piece to be divided. So the whole thing needs to go to the bottom. So you just want to kind of group that after your parentheses so the whole thing goes down. So then you're going to have log base 10 of 3. And then what? Plus log base 10 of y. Good. If you do not put that in parentheses, the way math works, you would have assumed that this piece would have went to the bottom, the fraction. But if you didn't put it in parentheses, I would assume this is being multiplied by the entire thing. So that would have went to the top again. So if you want stuff to stay on the bottom, if you have a whole group, you're going to have to group it into a parenthesis so I know the whole thing goes down there. Can you loopy swoopy any of those? If you look, 10 to what power is 4? Not pretty. That one's got a variable. 10 to what power is 3? Not pretty. And that one's got a variable. So I can't. But you always want to look. All right. Number 12. How many times will you write log? 2. I have the x piece and I have the 729. Okay. So log base 9. What am I going to do with that? How do you do the first? There should be a 4 in front. Good. Log base 9 of x. Do I need a parenthesis? I don't need one because it's just one piece. If you put one, not wrong. Okay? So then it would be log base 9 of 729. Does that become anything? 81. 9 to the 81st power? Exponents. Think in exponents. 9 to what power equals 729? To the third. So 4 log base 9 of x minus 3. It's different always having my classes flip-flop morning and afternoon. Students are very different. All right, 13. Ooh, how many times will you write log? Twice. You have 9 and the x. They're being multiplied. You know what? Do this one on your own. All right, 13. How many times did you write log? Twice. So log base 3 of 9 plus, good, 5 base 3 of x. It is a plus because it's being multiplied. And don't forget exponents get thrown in the front. This is 2. 3 squared equals 9. So that's 2. And that one's got a variable, so nothing I can do there. Can I add these? No. Emma, I love how you're like, no. You are way more awake in the morning than you are in the afternoon. So for you in the morning, math is a good thing. I like it. You're more awake. Yeah.
So I got that right-ish. I wrote a subtraction sign. Because,
Wrong. There's no ish in math, right?
Well, obviously.
I had a minus instead of a plus, so it's close enough.
Well, I just wrote a minus because I was like used to it.
So you got to be careful, right? Just got to be careful. All right. And I believe Ben's response was, I don't like 14, is what he said.
Oh.
I wonder why. Why does he not like 14?
It's a log of the square root.
There's a radical on there. That's not fun, right? All right. Well, we always kind of have been thinking in terms of exponents, right, with logs? How do you write a radical as an exponent? That's 1/2. So I could think of this really as 3x to the 1/2 over 7. I mean, we should know how to switch that, right? That was all last chapter, was rewriting from radical form to exponential. Actually, overall in that test, actually wasn't that bad. What? They're in. Actually, once we get through the notes today, I'm going to pass those back so you can see them. All right. So from here, how many times, let's kind of talk first. How many times will you write log? 3. You have the 3, the x, and the 7. You should write it 3 times. All right. So let's kind of think for a minute also. This exponent, it goes to the 3 and the x, right? So how many times will that be thrown out in front? Twice. It has to go to both of them. So you're going to have 1/2 log base 10 of 3, right? Because that 1/2 goes on that 3 as well. And the 3 and the x are being multiplied, so it's plus 1/2. Good. Log base 10 of x. Because again, it's got to go to the 3 and the x. It's on both of them. minus, because I'm dividing. Do I need a parenthesis? It's only one thing. Could you put one if you want one? You betcha. Log base 10 of 7. And then I always want to go back, can I loopy swoopy any of these? 10 to what power is 3? That's got a variable. 10 to what power is 7? No. So I am done right there. Don't you see how fun these will be for me to grade? Please write nice. For solving purposes. In the real world? The section that we did the day before yesterday, where we had all of those formulas about exponential growth, and we talked about your money and all of that, the bank accounts, that's very real world, right? You can see where all that stuff comes into play? Okay, like Zion just asked the question. Let's say you put $1,000 in a savings account. You know what the interest rate is, and you're like, when is my $1,000 going to become $5,000? Okay? You could plug the info into those formulas and then solve it for t, which is an exponent, which you need logs to solve for exponents. So this section's kind of that step. We always have those stepping stone sections. This is a stepping stone section to kind of get us to that next part. We're going to get into solving next week. Well, something similar-ish or whatnot. Yeah. There's no equal sign in that, so I can't solve it. But yeah, this is our stepping stone section to get to that. And your whole Google, where do you think calculators and all of that get their info from? Stop it. It's from knowing how to do this. It's logs. Google. Google runs the world. All right. 15. Google knows everything. All right. 15. What should you do before I even start to expand this? It is going to be 2 logs. But I need to change. I can't have a radical in here. That's a half. Yeah, so this is 2x 1/2. So does the 1/2 go to the 2 also? No, that 2 is not under the radical. They were both under the radical. Yeah, and only one of them's under the radical this time. All right, but you were right, it's 2 logs. So log base 5 of 2 plus, good, 1/2 log base 5 of x. Can you loopy swoopy any of these? 5 to what power is 2? Wow, you got to be smoother with it if you're going to say it. Don't hesitate. And that one's got a variable, so I can't do anything. $16. Oh.
That's still not that bad. Is that fish now? Is that 3 attached to 5? Yes, or 1/3 attached to 5. Like 2/3. Oh, it's 2/3.
That's a cubed root.
Okay.
That's a cubed root.
So it'll be log.
I can see why that could be confusing when that was written. Yeah. All right. So let's rewrite this as 5x to the 2/3. So does the 5 go to that 2/3 also? No, it's out of the radical. Log base 3 of 5. Thank you for reading that correctly. Hamid sounds like those little kids who just repeat everything you say and it drives you nuts. Ooh, loopy swoopy. 3 to what power is 5? Okay. Gotta look though. They sneak in there sometimes. You think you're good and you're not. Can we condense again? Now it's spread. Can I bring it back? What does that 3 mean when it's out front? It was an exponent.
So it's x squared plus
Nope.
1. So x to the 3rd, x cubed, log base 10.
Hold on.
Log base 10, x, and exponent is half. What is 3rd times log base 10,
If I'm condensing, how many times do I write the word log? once. Condensing means I write log once. I like those. I can be lazy. So let's deal with just the first one. Okay. What does the number out in front stand for? That's an exponent. So really, this is x to the 1/2. Yes. So that's actually a radical. That's the square root of x. Remember, whoa, she's like, what? Are you okay that this number out in front is an exponent? So it came back as half. All of chapter 6, we talked about how to switch them back and forth. Roots grow underground, right? So that's the square root of x to the first. Yeah, remember we talked last chapter, you can't leave a fraction for an exponent. It's considered not simplified. So we still need to follow that same rule here. All right, and then there's a plus, which means multiply. What's the 3 mean? That's an exponent to that. So I'm being multiplied by x plus 1 to the third. We are condensing. Condensing means I'm using my properties to kind of stick it all back together. It's kind of fun to do that. All right. Do number 18. $10.02. The first block of the day contains the success time attached. Yeah, we get to hang out for another hour, you guys. Aren't you excited? You guys will eat lunch with whatever your A block teacher eats. So that's your lab teacher. Whatever lunch your lab teacher has, that's the lunch you will eat. All right, come on, guys. Stay with me. Here we go. So number 18. The 2 out in front, that implies is an exponent. So it is log base 10 of x plus 2 squared. I caught at least 2 of you, but I didn't even walk around all of you, had changed that to a radical. If this was a half for an exponent, then yes, it would switch to a radical. But since it's a 2, it would just stay squared. And then this is minus, so that means divide, and x. Now, the question always comes up, where do I put my log? Do I put him on the top? Do I put him on the bottom? I just kind of don't even make him part of my fraction. He just kind of hangs out up front. Okay, do you see the fraction did not go underneath him? He's just kind of hanging out in front. Yes, it would be. Because if we flip, yep. Right, like here, the log, see how he's just kind of out in front? He's not top nor bottom. He's not underneath. He's not part of that fraction at all. Because if you would stick him as top of the fraction, it would imply that the log is only with what's on top and not the bottom. So yeah, you want to kind of leave him out in front. If you put him underneath, there, I'm going to count it wrong. Okay? Yeah. Sure. All right, can I loopy swoopy anything? No, there's variables in there. I'm good. Look at that one. Isn't it pretty? What are those things called? Brackets. Yeah. Emma's awake this morning. Don't mess with her. She's going to come after you. All right, guys, the reason there's brackets here instead of parentheses is because there's parentheses here. So the next type of parenthesis is a bracket. And then you know what's after those? Yeah. They're called braces. I call them squigglies because that's more fun to say. You ever try to make those? I remember when I was in high school, my teacher would write those. And I'd be like, man, how do they do? I would like sit and like practice, and they always looked so bad. Right. Try it out. You know, some of you right now are thinking about it, right? Like, can I make those? This was like 6 years of college math classes that allows me to write them that nicely. So see, yeah, like I remember when I was in high school, they looked more like this. Sometimes they weren't even that good. You're all writing them right now, aren't you? The good ones? That'd be kind of fun. Yeah, okay. Did you get a good one? Now I got to see. That's not bad. Way better than your first 2. All right. Anyway, Here we go. So the 1/3 out in front, since it's in front of that lovely bracket, what does that mean? It goes to everything. That's what that means. It's like I have a distributed. It goes to everything. So this 1/3 goes to the x, and it's going to go to this over here. It's going to go to both parts. So I have log base 2. Right? If I'm condensing, I write log 1 time. The number in front comes back as an exponent, so that's x to the 1/3. And then I have a plus sign, which means multiplying. Whoopie swoop. The 1/3 was in front. Yeah, we're condensing. And then we're going to have x plus 1. That also goes to it, to the 1/3. It just means the number out in front just got distributed to both parts. It goes to both of them. Now, I can't leave an exponent that's a fraction. Nope, pulling out to front is not me condensing everything back. What's a 1/3 for an exponent imply? It is the cubed root. So log base 2, they're both under cubed roots together, right? 1/3, 1/3. Cubed root of x times x plus 1. And I can't loopy swoopy because there's variables there. Emma? Oh yeah, we'll do a burn break. Pretty much.